Hello. In this video, we will be talking about the normal distribution and we will be solving applications with the normal distribution. Let's just take a look at steps for finding probability of a normal distribution. First, draw the situation. Remember, turning points are 1 and 2 standard deviations from the mean, and the mean is in the center of the axis. Use normal CDF to find the area under the curve. Now, looking at these instructions, you do realize that this is exactly what we've done in the first video with normal distributions. To be more specific, in the standard normal distribution video. And we are repeating the process. And the only difference that you will see in here is related to the fact that when you use normal distribution, you want to make sure you plug in these formulas, the mean and the standard deviation pertaining to the specific situation. So to find the probability that X, and I want to point this out, X is less than K, X is not Z anymore. We did these problems using the standard normal distribution, and in that situation, we used Z in here, not X. But now, because we are talking about the normal distribution or any normal distribution, we will have X in here. The process is the same. Normal CDF is the function in the calculator. And if we are looking for an area in the left tail, we start with negative infinity up to K. And this mu and sigma will be found in the given information. This time, this will not be 0 and 1 as they were when we are talking about a Z or standard normal distribution. The process is the same, and the formulas are actually the same formulas. Again, keep in mind the only difference is right here. All of these are actual data, X, not standard score anymore. And all of these are actual mean and standard deviation values. So we'll go ahead and solve a couple of problems. The repair time for an air conditioning unit is believed to have a normal distribution with a mean of 38 minutes and a standard deviation of 12 minutes. What is the probability that the repair will be between 30 and 40 minutes? The second question, what is the probability that the repair will be longer than an hour? Let's write down the given information. We are talking about a normal distribution. It's right here with a mean of 38 minutes and a standard deviation of 12 minutes. So let's use the corresponding symbols. And the question, what is the probability? And I'll write this down this way. Probability that the repair is between 30 and 40 minutes. This is how you write this down in symbols. And the second question, what is the probability that the repair is greater than 1 hour? Let's get started, and I will show the solution for the first question first. And I will start by sketching the graph. This is a normal distribution, and this is about time for repairing some air conditioning units. So this is time, repair time. This is actual data, X. And we know the mean is 38 minutes. This is given in minutes, time in minutes, okay? And now we will be focusing on the value of 30 and 40 minutes. 30 minutes will be somewhere to the left. I don't know where it is, so I'll just say 30. And 40 will be close to 38, so I'll just put these numbers down, okay? And now I know I have to find this area because that will answer the question related to probability that the repair time is between these two values. So I'm looking for this area. In order to find the area or the probability, I know I'll have to use normal CDF on the calculator. So I will simply say probability that X, so this is an X, is not a Z anymore, keep that in mind, is between 30 and 40 equals normal CDF. And let's just look at the lower and upper bound. Here is one lower, and here is the other one, which is upper. So I'll just simply plug in 30 to 40, and the mean is 38, and the standard deviation is 12, because this is an application where I talk about X, not Z anymore. I'll have to make sure I change the mean and the standard deviation accordingly. The beginning or the lower bound and the upper bound will be the numbers that are bounding this area on the x-axis, and the area is actually the probability, and it's found with normal CDF. So let's take the calculator. Here is the calculator. I will go to distributions, second bars, normal CDF, hit enter. I'll just simply say 30, hit enter to 40. Now the mean is 38 and the standard deviation is 12. So this is the difference between what we showed in the previous video, where there were problems related to the standard normal distribution, and this video where the problems are related to applications to any normal distribution. So this is how the screen looks like. This is the information, hit enter, and the area is 0.314. So I'll just simply write down the answer is 0.314. In other words, 31.4% of the repair times are between 30 to 40 minutes. So let's just interpret this, try to make sense of what we are doing here. 31.4% of the data, and the data in this case is related to repair time. This percentage is between 30 and 40 minutes. In order to answer the second question, I will have to sketch the graph again and show the solution. So let's do that. Here it is, my new graph. Again, we're talking about time, which is given in minutes. This is X. And right here in the middle, we have 38 minutes, which is the mean. And we are looking for the probability that the repair time will be longer than an hour. Because our information is given in minutes, we'll have to make sure we convert this to minutes. So actually, to answer this question, I'll say probability that X is greater than 60 minutes. So this is important. Convert it to minutes. And then I will go ahead and sketch the graph. So right here, I have 38 minutes. So 60 minutes will be here somewhere. I know it's to the right. And I will shade the corresponding area. I'm thinking which area to shade. Greater than should be this area, right? Now, if it's easier for you, look at the symbol for inequality. This one, if you look at it as an arrow, it will point out to the right. So it shows you where to shade if you're unsure where you should shade. So this is what we are looking for. What is this area? Well, in order to answer this type of questions, we know we have to use normal CDF. So I'll simply write down normal CDF, and I have to enter the lower bound, the upper bound, the mean, and the standard deviation. This is how it works. We know that by now. So lower bound, this area, it's lowered. This area, it's bordered by 60. And then as an upper bound, well, that will be infinity. 60 and infinity, we all know in the calculator should be written as E99. The mean is 38 and the standard deviation is 12. Well, actually this is where we have the given information. And that's all you need in order to solve problems. Let's go ahead and do that. Second bars, normal CDF, hit enter. It's from 60 to infinity. Second comma gives me the E99. And then the calculator already has the 38 and 12 in there because we've done a problem with that. This is how it should look like. And scroll down, paste it, hit enter. The answer is 0.033. What does this mean? Let's interpret this result. It means that about 3.3% of the repair time will take more than an hour. Let's take a look now at another example. Write the probability in correct notation. Draw the normal curve and shade the correct area. Find the probability using a calculator. This is how we usually do this type of problems. So let's read the problem. The lifespan of batteries are normally distributed with a mean of 2,000 hours and a standard deviation of 30 hours. What percent of batteries have a lifespan that is more than 2,065 hours? So we want to make sure we understand the problem. I will write this again as a given. We are talking about a normal distribution. We know the mean is 2,000 hours, and we know that the standard deviation is 30 hours. So that's all we need in order to solve problems like this. Remember, if you have this, you have a key. You just need to know how to use the key to open many, many doors. Question, what percent, in other words, what is the probability that the batteries will have a lifespan more than 2,065 hours? So here we go, question, and I write this down in this symbol, probability, that X, because I'm talking about an X distribution, a normal distribution, right? More than means greater than 2,065 hours. And because we have the same unit measure, we don't worry about converting it into anything else. So in order to show the solution, we start with sketching the graph. Here is the graph, X distribution, and this time it's again time. This is given in hours. We have the mean of 2,000 hours, and we are looking for probability of batteries that have a lifespan more than 2,065. So 2,065, well, I'll just put it here somewhere. And I'm using this to shade one of the regions under the curve because it says more is pointing to the right. So here is the area or the percentage, percent area probability. This is what we want to find. In order to find that, we will simply use normal CDF. So I'll write this down again. Probability that X is greater than 2,065 hours is normal CDF. Looking at the lower bound, 2,065. Looking at the upper bound, well, there is no end to this, right? So that should be infinity, which we know this is E99, as we put it on the calculator. The mean is 2,000 and the standard deviation is 30. So don't forget about adjusting these two values. These two values are actually written right here, very important values, because we are talking about an X distribution this time, not a Z distribution. And only on the Z distribution, we keep those as 0 and 1. So if we use the calculator to figure this out, we will simply take the calculator, go to second bars, normal CDF, hit enter, and plug in the correct numbers, 2,065 to E99. And this time we have 2,000 and the standard deviation is 30. Hit enter, and we see that the answer is 0.015. If you think of what this means, it tells us that about 1.5% of the batteries have a lifespan that is more than 2,065 hours.